A stone is projected from a point of ground in such a direction so as it hit a bird on the top of a telegraph post of height h and then attains the maximum height of 2h above the ground. If at an instant of projection the bird were to fly away horizontally with a uniform speed, find the ratio between the horizontal velocity of the bird and the stone if the stone still hits the bird while descending. So जो उसका मोशन का डायग्राम रहेगा, let us say this is the x-axis and this is the y-axis, and the stone is thrown like this. So this is the trajectory of the stone, and it hits the bird of a pole whose height is given by h, and the initial velocity of the projectile is u and angle of projection is theta. So as soon as the stone is projected from this point O, the bird starts to fly in the horizontal direction this way, and the stone still hits the bird when the stone is descending. So it means at this point the height will be still h, and the maximum height, let us suppose this is m and this is n, this is given as 2h, and let us suppose that A and B are the 2 points where A is the initial position of the bird and B is the final position of bird which being hit when the stone is at the descending. So we can divide our initial velocity of the stone in x direction as well as y direction. So we can write u of x is equal to u cos of theta, and u of y is u sin of theta. Acceleration in the y direction will be given as minus g. So in the question it is given that the maximum height attained by the stone is given at 2h. So by the formula for the projectile, maximum height, max height of the stone is given as u square sin square theta divided by 2g, and in the given question it is given as 2h. So from here we can find out u sin theta will be equal to 2 square root of gh. Let us call this question number 1. So if the t is the time of flight of the stone, if t is the capital T is the time of flight, of stone, and small t is the time taken to reach the point A. T small t is the time taken by the stone up to point from O to A. So during this time the vertical height that will be traveled by the stone will be equal to h. So we can say the vertical height of stone in t time is equal to h. So vertical height of the stone in t time will be equal to h, where t, small t rather, is the time taken by the stone from O to A. From O to A, let us suppose the time taken by it is given as small t. So using the kinematics equation in the vertical direction, we can say that by equation of kinematics in vertical motion, we have Sy is equal to u by t plus half a by t square, and Sy is given as h. Uy we already know is given as u sin theta into t. Ay is minus g, so this will be minus half g t square. From here we can solve it out. We can write this as half g t square is equal to u sin theta into t minus h, and we can make it a quadratic in t, so this can be written as t square minus 2u divided by g sin theta plus 2h divided by g will be equal to 0. So this is a quadratic in t, and here t I missed it. So we can use find out the roots of this equation. So the roots of the equation will be given as minus b plus minus square root of b square minus 4ac. So this will be minus b, so that is 2u divided by g sin theta plus minus b square, that is minus 2u g sin theta whole square, and minus is minus 4ac, 4 into 1 into 2hg divided by 2 multiplied by a, so this is t. So we can further write it as so we can take 2 common from the entire equation, so we can take 2 as a common, so this will be coming as u sin theta divided by g plus minus square root of u square sin square theta divided by g square minus 2h upon g. This 2 cancel out with this 2. So we can write t now as t will be equal to, let me write the PV equation first. So 2 cancel out with 2, so let this t will be equal to, now t will be equal to u sin theta divided by g plus minus square root of u square sin square theta divided by g square minus 2h upon g, and we already found out that u sin theta will equal to 2 square root of h. That was our first equation. So we put this value here as well as here, so this will be equal to, substituting u sin theta here as well as in this part, so we get 2 square root of hg divided by g plus minus, this will be 2 into, so rather 4hg divided by g square minus 2hg. So this will become written as, taking 2 as well as g inside the square root, this will be coming as 4hg divided by g square plus minus g square cancel with this g, so this will be 4h upon g minus 2hg. So considering only the positive values, g cancel out with g. Let me write first of all, this is 4hg plus minus, and this will be coming as 2hg upon g, so this will be t. So let us suppose the roots of t are given as T1 and T2. So we can write that T1 will be equal to 4hg square root plus 2hg, and we can take 2hg as a common, 2hg, and this will be square root of 2 minus 1. Similarly, T2 will be equal to 4hg square root minus 2hg, taking again common, 2hg, this will be square root of 2 minus 1. Okay, now we have to find out the horizontal velocity of the bird. So if we draw the diagram again, it will be coming like this. So this is A point, this is B point. So if time T1 is here and T2 is here, and V is the velocity of the bird in this direction, so we can say that AB will be equal to V multiplied by T2. Okay, so we can write that if T1 and T2, if T1 and T2 are time at A and B respectively, and V is the horizontal velocity of the bird. So we can say that distance AB will be equal to V multiplied by T2. So AB, we already wrote it as AB is equal to V multiplied by T2, and AB with respect to projectile motion, that is horizontal distance of the projectile, horizontal distance for projectile, where projectile in this case is nothing but a stone. So in that case, the AB will be equal to horizontal velocity Vx and the difference between time, that is T1 minus T2. So Ux we already know is given as U cos of theta T1 minus T2, or rather we can say, because we have taken, let me correct it here, let us call this as T2 and this is T1, because T1 is positive, so T1 will be higher as compared to T2. So now the time T1 and T2. So here also let me make the correction. This will be T2 and this will be T1. So the time T2 is at A and time, so here that correction, because T1 is positive, that T1 will be higher, so this will be T1, this will be T2. So T2 will be time at A and T1 will be time at B. So this will be T1. So now it's correct now. Okay, now AB will be equal to AB. So we can say that V into T1 is equal to U cos of theta multiplied by T1 minus T2. So horizontal velocity of the bird divided by horizontal velocity of the stone is given as T1 minus T2 divided by T1. So this is the ratio of their velocities. Thank you.